Hello dear students, welcome to Pen and Paper Chemistry on YouTube. The topic that we are taking up now is called electrolysis, and we are on to part 3 of this particular topic. In part 1 and part 2 we have covered the basic definitions and the electrolysis of acidulated water. Today we are going to cover a lot of things in this particular heading. The first and foremost that we are taking up here is the electrolysis of copper sulphate solution using platinum electrodes. Now as soon as we see the word platinum over here, it means that we are talking about an inert electrode, that is an electrode which will not participate in the reaction. Copper sulphate on dissociation gives you copper ions and sulphate ions. Water on ionization gives you hydrogen ion and hydroxyl ion. We already know that hydrogen ion as such only means a proton, so it does not exist independently. So actually the hydrogen ion exists in combination with the water molecule and it is H3O positive. But for the sake of simplicity, we will usually find it written as H positive and OH negative in most of the places. If you are not comfortable, you can also write it as 2H2O gives you H3O positive plus OH negative. We can also write it like that. Now let us see what happens when the ionization or after the ionization has taken place. Cathode, cation, ion with a cut, goes towards cathode, Cc. Anion goes towards anode, right? So the cations, we have two cations over here, copper and hydrogen. Copper and hydrogen both are competing with each other in order to take up electrons. Copper needs 2 electrons, whereas hydrogen needs a single electron. So what decides whether both of them or only one of them gets ionized? It is the position in the electrochemical series. So there is a whole series listed out for them. Okay, you are going to follow this particular rule. And in that EC series, if you realize and if you recall what we have done in electrochemistry, the reduction potential of hydrogen is 0 volts, right? Whereas the reduction potential for copper, E naught Cu2 positive Cu, is 0.34 volt. That means copper has higher tendency to get reduced compared to hydrogen. So copper gets priority over here. Cu2 positive plus 2 electron gives you Cu solid. Copper is a reddish brown metal. So what happens is we notice that reddish brown powder deposits at the bottom of this beaker, and that reddish brown powder is the copper. What else will you notice over here? If you notice, I have drawn the blue dashes over here. The blue dashes are for the copper sulphate solution, right? Because copper ions impart blue color to the solution. Because copper ions are getting discharged, so that means the number of copper ions in the solution is decreasing. Because the number of copper ions in the solution is decreasing, what will happen to the color of the copper sulphate solution? Yes, the color of the copper sulphate solution will start becoming faded. Correct? because the copper ions are disappearing from it. They are getting discharged and they are not getting replenished as well. Let us now go on to the anode. We've got hydroxyl ions and we've got sulfate ions. Now there is again a war between both of them. I get discharged, I want to lose electrons, I want to lose electrons. Now if you notice over here at the anode, what takes place is, yes, oxidation. In other words, it depends on the oxidation potential of any of these ions, which will decide as to which ion gets oxidized. Now in order to do that, we can also compare their reduction potential, but it will be the reverse. In order to compare the reduction potentials, if you remember, I had given you a simple sentence in order to recall what will get discharged. Yes, absolutely right. So hydroxyl. Can you recall? If you are not clear about this, we have already covered it in part 2. So I had given you a simple mnemonics. Oh, I brought colors, not safe, for activity. Why activity? Because we are talking about the activity series. O is OH negative, I negative, brought is for bromide, colors, chloride, not nitrate, safe, sulfate for F negative. So in this series, if you see, hydroxyl has the best tendency to get discharged. So what do we do over here? OH negative, right? Let me make some space for you so that there is more clarity over here. OH negative will lose electrons. Now when it loses electrons, it becomes OH. Have you ever heard of a molecule like OH? No, it does not exist, right? So what happens is OH particles come together to give us H2O and O2 over here. We need to balance this. It's not balanced, right? So 2, 3. So we put a 4 over here and we put a 2 over here. Now is it balanced? Yes, it's balanced. Now because there are 4 OH atoms involved, or so 4 OH species involved over here, 4 OH has to be released also, right? So I multiply the first equation by 4. 4 OH being generated, 4 OH being used, we are left with, yes. Can you write the final equation over here? Go ahead. Can you give me the final equation for this reaction? Yes, it is 4 OH negative, because we have multiplied the first equation by 4, gives us 2H2O plus O2 plus 4 electrons. In most of the text, you will find the equation written like this. I have split it for ease of understanding. This equation in itself has no meaning. It is this final equation which makes sense. So what do we have over here is, which gas is evolved at the anode? Yes, it is oxygen which is evolved. And water, out of here, water is being regenerated. So ultimately what is happening is, copper ions from the solution are getting discharged at the cathode. So the color of the copper sulfate solution begins to fade away. Now let us see what happens when we replace the platinum electrodes by copper electrodes themselves. Now copper compared to platinum would be an active element because it does participate in the reaction. We have to see whether it will participate in this process or not. Of course, we don't say that copper is highly reactive, but compared to platinum, yes, it does undergo a chemical reaction. Before we proceed to the next electrolysis, that is electrolysis of copper sulfate solution using copper electrodes, a request. Please fetch a pen and paper so that you are able to relate to what I am teaching over here. It is very easy to browse through the videos, but the whole experience and the whole understanding only comes when you write it with your own hand. So earnest request, please pause the video, go and fetch a paper and pencil, so we can go ahead with the next electrolysis. I am waiting. Very nice of you to have followed the instructions and have got the paper and pen. Electrolysis of copper sulphate solution using platinum electrodes. Let's suppose it's platinum electrodes. Can you just write down these reactions so that you have something to compare with when I start explaining the copper electrodes? That is why I have not rubbed off the initial set of the reactions. So when you have platinum electrodes, copper sulphate, water, they dissociate, cathode, cations, copper gets discharged, reddish brown deposit, anode, anions go towards anode, hydroxyl gets discharged, and if you want the mnemonics, you can note this down as well, right? And we are good to go with the second set of electrolysis, that is electrolysis of copper sulphate solution using copper electrodes. Copper sulphate solution, that means the initial reaction will remain the same. Copper sulphate dissociates, water ionizes. Can you try and write the reaction yourself so that we can discuss it further? Try covering the work and try writing the answer yourself. This will build up your confidence also in the topic. Go ahead. Yes, just the initial reaction. Now go on to cathode. We've got copper ions, we've got hydrogen ions. There's a competition, electrode potential of copper being higher, that is 0.34 volt, compared to hydrogen, which is just 0 volt taken arbitrarily as 0 volts. Copper gets discharged, and here copper is a reddish brown powder. Now here what will happen is, because we are using a copper electrode over here, the copper deposits onto the copper plate, right? Does this help? So what will happen is the copper will get deposited onto the cathode, right? Now let's go to the anode. What is the reaction that takes place at the anode? Yes, hydroxyl and sulphate, again fighting with each other. I'll get discharged, I'll get discharged. Now something interesting over here takes place. While the two cats are fighting with each other, there hops in a monkey. And that monkey is the copper from the anode itself. What does it say? Oh, while the two of you are fighting with each other, let me lose electrons and go into the solution as copper ions. Because although I am not so reactive, but still I am still active, right? So copper ionizes to give you copper ions plus 2 electrons. So with the result, now I have copper ions which have come into the solution. These copper ions now are the cations, right? And cations go towards, very good, they go towards cathode. So with the result, what is happening ultimately is, from the anode, the copper is getting discharged and getting collected at the cathode, right? Cathode is the one which is connected to the negative terminal of the battery. So let's suppose if you had started off with a cathode which is small and an anode which is big. So this is your cathode and this is your anode. This is what we had started off with. Then at the end of the reaction, the situation would be something like this. So wherein what will happen is, the cathode will become bigger in size, whereas the anode would have shrunk, right? So in this case, neither hydroxyl nor sulfate ions have got discharged. So if you notice, just by mere changing of the electrode, the product of the electrolysis will also change. Also, what will happen to the color of the copper sulfate solution? In the earlier experiment, we had said when we were taking platinum electrodes, we realized that because the copper ions are getting discharged, the color of the copper sulfate solution fades away. What will happen here? Yes, copper ions are getting discharged, but at the same time, at the same rate, they are being replenished from the anode. So what will happen is the blue color is retained, right? The blue color of the copper sulfate solution does not fade away. Now let's suppose if at the anode I take a metal like silver maybe, and I have an article over here, let's say a spoon. What will happen? And we have a solution containing silver ions instead. What will happen? Absolutely. The silver ions from the anode will move to the electrolyte, and from the electrolyte the ions will get deposited at the cathode. So what does it remind you of? Very good. It reminds us of electroplating. That is why you have so many articles these days: silver plated articles, gold plated articles, nickel plated, chromium plated. So this is how it is done. We will come back to this. Also, when you do this electrolysis, electrolysis of copper sulfate solution using platinum electrodes. Now at the cathode, what decides the discharge of the ions? Yes, it is the electrode potential. So let us first list down the factors which affect the discharge of the ions when we talk about electrolysis. Hope you have noted this down, because this becomes as part of your notes as well. From the three electrolysis reactions that we have done till now, let us try and reason out what are the factors which affect the products formed during electrolysis. The first and foremost that we've seen in the two electrolysis that we did just now in part 3, because it's immediate recall, is the reduction potential of the ions. So when you had a choice between copper and hydrogen, which one of these was getting discharged? Yes, it was copper. So it was the reduction potential of the ions which decides as to which one is going to get discharged. Same way for hydroxyl also, hydroxyl and sulfate, we could, looking at their reduction potential, we could say as to which one of these will get discharged. The second is the nature of the electrode. So we had electrolysis of copper sulfate using copper electrodes and using platinum electrodes, and we noticed that the product obtained at the anode vary depending on the electrode that you have used in the course of electrolysis. Third and fourth is what we will be covering in the next lesson, is where we talk about the state of the substance. So when you, let us take sodium chloride in the molten state, or you electrolyze sodium chloride in the solution state, is what we are going to discuss in the next video, how it affects the products of electrolysis. And fourth is the concentration of the electrolyte. We shall be discussing part 3 and part 4 under electrolysis part 4, lesson part 4. Now when we've done copper sulfate solution using copper electrodes, there are some important applications that we can see from electrolysis. Before I go on to the applications, please remember your cathode is the one which is connected to the negative terminal of the battery. Your anode is the one which is connected to the positive terminal of the battery, right? Whereas your cation is the one which is the ion with a cut. A cation has positive charge on it, and anion on the other hand has a negative charge on it, and this all we are talking vis-a-vis an electrolytic cell. So when you are asked to draw an electrolytic cell, please make sure that you draw the electrodes, and along with it you don't forget to show the battery arrangement and the key arrangement, right? And you have to mark everything. The electrolyte, the cathode and the anode, the battery, the key. First, the basic reaction, the dissociation or ionization reaction. Then is the reaction at cathode. Then is the reaction at anode. And last and most important is the observations that you make during any electrolysis process. So whether the color disappears, fades away, what color of deposit do you see, and what are the advantages of it. So after you draw an electrolytic cell, list down the anode, cathode, basic reaction. Once you have this data tabulated on a sheet, this becomes very, very easy and you don't get confused, right? And all these are important points. So please draw this for, let me give you a task. Can you draw an electrolytic cell showing the electrolysis of copper sulphate solution using copper electrode? Again, pause the video, draw it. Draw it. I know you will be able to solve it very quickly while I'm speaking as well. You'll be able to draw, but just draw it for your confidence. Go ahead. Let me see who's faster, whether I rub the board faster or you write the reactions and the cell. Complete all the reactions. You can see it from what you've already written, because I don't expect you to know it immediately. Right. Now this particular cell that you have drawn helps me to guide you to two important applications of electrolysis. First is the purification of metals. For example, I can purify copper using this method. As I explained, if we start with a cathode which is very small and an anode which is very big, right? So the positive rod anode is thick. So this is, let's suppose my anode is impure copper, whereas my cathode is pure copper. When I carry out the electrolysis using copper sulphate solution, simply the ions of copper will move from anode to the cathode. So the size of the anode begins to reduce, whereas the size of the cathode begins to increase, right? So can we tabulate it now? Let's tabulate. So it's easy for us to recall as well. So when you're talking about purification of metals, your cathode will be the pure metal, right? Whereas your anode will be the impure metal. The beauty of this process is, what happens when I'm talking about impure copper. Impure means there are other metals also present. In impure copper, the other metals which are present are like silver, gold. These settle down at the bottom of the beaker during the process of electrolysis. They don't get dissolved. They settle down, and we also call it as anode mud. Now this is made up of precious metals. What do you get by selling? You know the price of gold, you know the price of silver, right? So otherwise the whole cost of this process, because we are using electricity over here, will be very high. But because we are recovering anode mud at the same time, the cost of this process is recovered, right? So this is the beauty of the entire process. It self-sustains in terms of cost. Not that it is giving us impure copper from somewhere, but in terms of cost, we are able to recover the cost from this. Let's talk about electroplating. So I gave you the example that if I want to electroplate an article, so let's suppose I want to electroplate a spoon with silver. So what will be my anode and what will be my cathode? Just ponder over it for a minute and then check your answer. It will do you good. It will give you that confidence. Yes, your cathode will be the spoon, or let us put it down as the object to be electroplated, because we are getting the metal to deposit onto it, right? What about the anode? Now what will be the anode over here? Yes, it is the metal to be electroplated. So if I want to coat it with silver, my anode will be made of silver. If I want to coat it with gold, my anode will be gold. Chromium, nickel plated. So many options are there in electroplating. Can you suggest a third column for me over here? That means what can we put in the third column? Yes, we can also talk about the electrolyte. What electrolyte will you take in each of the two cases? Yes, very important is that the electrolyte should have the ions of the metal which I want to electroplate or I want to purify. So when we are talking about copper sulphate solution using copper electrodes, if you notice, we have copper ions in the solution. Same way for electroplating, we do have a concentration, we have a solution containing silver ions, right? The electrolyte should have the ions of the metal to be electroplated. But the process of electroplating, it's not that we do it in a jiffy, we don't do it, we go slow with this process. Slow and steady wins the race. We pass a small current for a longer period of time. We ensure that our article is clean, because if the article is not clean, then we will not have a uniform coating on that article, right? There are other advantages as well of electrolysis. Can you find out some more for me and put them in the comment section? It will be interesting to see how many of you are noting the questions that I have given you so far. Electrolysis part 4 is what we will be taking up next. As I already mentioned, we have to discuss the factors affecting the product of electrolysis. 2 we have done. 3 and 4 is what I will be taking up next. Happy studying to all of you. Stay subscribed, stay in touch.